This video will go over some of the compressors available in VapCyc. There are three types of compressor models available: physics-based, map-based, and two-staged. The generic compressor with constant efficiencies is a physics-based model that uses displacement volume, volumetric efficiency, and mechanical efficiency to determine mass flow rate, and also uses the isentropic efficiency to determine the outlet condition. Users can define these values themselves. There are also precise capacities for different refrigerants, capacities, and types of compressors, and when one is selected, needed values are automatically filled in below. The 10 coefficient database compressor model version 4.0 is a map-based compressor based on the AHRI 540 standards, and it uses 10 coefficient equations for modeling compressor mass flow rate and power consumption. It relies on loading a database of compressor coefficients, and there are pre-made templates included with the VapCyc software package. A user can load a pre-made database by selecting Browse, Program Files, UMCP CEE, VapCyc, and then clicking on Sample Performance Data and selecting the database file they want. In this example, we will be using the file name database compressor version 4_10coef_template. A preview of this template shows that it includes a variety of information including manufacturer, model name, and key identifying information. It also includes coefficients for capacity, power, amperage, and mass flow rate. Users can modify these to reflect their specifications, but make sure to keep the format the same so VapCyc will be able to read the database. After the database is loaded, a user can use the various filters to quickly find specific models in the large database. They can also change the values for motor efficiency, mass flow rate, and power correction factor, and they can also change the superheat correction factor. In the Calculate tab, they can enter or select evaporating and condensing temperatures and calculate the performance based on these new conditions. Both English and SI units are available. The 20 coefficient variable speed database compressor model is also a map-based model and is similar to the 10 coefficient model, but it is used for a variable speed compressor. It takes into account the RPM of a compressor and thus uses twice as many coefficients to measure a compressor mass flow rate and power consumption. Once again, a user can create their own database or load a pre-made template available in the same location as a 10 coefficient template. In this example, we will be using the file called database compressor version 4_20coef_template. A preview of this template shows that it includes pretty much the same information as the 10 coefficient file, except it has 20 coefficients for capacity, power consumption, amperage, and mass flow rate. It should be noted that RPM can be modified on top of motor efficiency, power correction factor, mass flow rate correction factor, and changing the superheat correction correlation. The Calculate tab can also be used the same way as in the 10 coefficient model. The 10 coefficient compressor rack is another map-based compressor that uses AHRI 540 10 coefficient equation standards. However, after loading your database file, you are able to select the compressor models you want and change the number of compressors for each individual model. These compressors are modeled all in parallel. The user-defined performance map compressor model allows a user to enter their own equations for mass flow rate and power consumption instead of using AHRI 540 based equations. This example uses a very basic equation, TEF plus TCF for both equations. One should make sure that the mass flow rate is inputted as units of kilograms per second, since other models deal with mass flow rate in terms of pounds per minute. Appropriate conversion factors should be included if this is not the case. Once you enter your equations, click on Check Equations for VapCyc to check for potential mistakes. Values can be entered under the Calculate tab to see if the results make sense. The two-stage compressor model with intercooler option is a single component model that contains a low and high stage generic compressor and an optional generic heat exchanger to be used as an intercooler. Users can set displacement, efficiencies, and RPM of both the low and the high stage compressors. To set the intercooler, click on the Intercooler Properties tab, use the checkbox to specify use of the intercooler, and modify the properties such as total tube length, inner tube diameter, air inlet temperature, air mass flow rate, fin efficiency, as well as fin ratio, and heat transfer coefficients for the air and refrigerant sides as deemed necessary.